Okay, so welcome back, and let us solve problem 23. So problem 23, basically we see this a hot reservoir, cold reservoir. We have a reversible Carnot cycle and a irreversible power cycle. And basically they ask you to find a few things depending on if part A, if each cycle received the same amount of energy by heat transfer from the hot reservoir, so basically QH equal to Q prime H, and the second one, if each developed the same network. So the work created by this power cycle here from the reversible is equal to the power created by the irreversible cycle. Okay, so let's just get started. And you know that I always like to do the figure anyway on the solution. That way I have time to think about the solution. Alright, so I put that on the side. And let me just do the figure. So we have over here a hot reservoir. So we're gonna have here Q hot, and here which would be Q prime hot. This will be connected here to a, let's say, reversible power cycle. This will be an irreversible power cycle, and this is connected now to a cold reservoir. So we'll have here this will be our cold reservoir, and we know that each one creates work. This will be irreversible, and this will be reversible. So let's see what we need to do. On the first case, the same. If each cycle receives the same amount of energy by heat transfer from the hot reservoir. So what does that mean? Case A, case lowercase a. Basically that means that Q hot will be equal to Q prime hot. Knowing that, what do we need to do is two things. So the first one is to determine which cycle develops greater network, and then this discharges greater energy by heat transfer to the cold reservoir. Okay, so basically let's do the first one. So basically case A, and okay, one thing I forgot to add, cycle irreversible has a thermal efficiency equal to 1/3 of the thermal efficiency of the cycle reversible. So we know that the efficiency of the irreversible equal 1/3 of the efficiency of the reversible. So maybe we can use that information here to solve for the first part. So by definition, what is efficiency? Is whatever we're trying to get out. So in this case will be trying to create power. What do we put in? Heat. So for the irreversible, that will be Q prime I. And for this one will be 1/3 of work created by reversible divided by Q hot. So in this case, since QH equal Q prime H, we can cancel these two over here, and we have that the work created by the irreversible is basically 1/3 of the work created by the reversible. Okay, or you could just say that the work of the reversible is 3 times the work of the irreversible. So either one is acceptable. So basically that means that if both operate with reference to the same hot reservoir, because of the efficiency, the work over here will be 3 times this one over here. Okay, part 2 of this problem, we need to find discharge greater energy by heat transfer to the cold reservoir. So basically, let's say we're trying to solve for Q prime C minus QC. Let's try to solve for this one. Okay, so in order to solve for this one, what do we know will be the work created by the reversible is always a difference in temperature between the hot reservoir and the cold reservoir. So that will be Q hot minus Q cold. The one of the irreversible would be Q prime H minus Q prime C. Okay, so what do we know? QH equal to Q prime H. So maybe we can rewrite here QH will be equal to what? Work of the reversible plus QC. And this one will give us Q prime H equal to work of the irreversible plus Q prime C. Since we know that QH equal Q prime H, we can equate these two equations and we'll have what? Plus QC will be equal to work irreversible plus Q prime C. So now if we solve, what do we get? Q prime C minus QC will be equal to what? Work of reversible minus work of irreversible. Or this would be equal to Q prime C minus QC equal to, we can do either one. So let's say it's equal to WR minus 1/3 of WR. So this would give what? 2/3 of the reversible. So what does that mean? If this is positive, that means that the amount of heat Q prime C is 2/3 WR bigger than the one of Q sub C. Alright? Now we do case B. So what is case B? If each cycle develops the same network, so each cycle develops the same network. So let's see case B. We have reversible equal irreversible. Alright. And the first thing we need to do is which one receives greater energy by heat transfer from the hot reservoir. Alright. Alright, so let's do this. Let's see what we can do. So over here, maybe we can use the same expression as before. The efficiency of the irreversible is 1/3 of the one of the reversible. Okay? Or this is the same as saying work irreversible Q prime hot as before equal to 1/3 work reversible over QH. But this time is the works, the one that are equal, not the heats. So we can cancel these two over here. And what we have is what? 1/Q prime H will be equal to 1/3 of 1/3 QH. Okay, or QH. Or okay, Q prime H will be equal to 3 QH. So again, as you can see, this time the amount of heat that you need to put inside the system in order to get the same amount of work, basically that means that this one here will be absorbing 3 times the amount of heat than this one in order to get the same work with this efficiency. It kind of makes sense, okay? You think about it. And Latin 2, we need to determine discharge the greater energy by heat transfer to the cold reservoir. So same thing as before. So we follow exactly the same procedure. We're going to evaluate Q prime C minus QC. And in order to do it, we do the same thing as before. Minus Q called equal Q prime H minus Q prime C. Okay, so this will give us what? Since these two are equal, okay, we can equate these two, so we'll have QH minus QC equal to Q prime H minus Q prime C. This will give us what? Q prime C minus QC will be equal to what? Q prime H minus QH. And this means, let me jump one line, so Q prime C minus QC will be equal to what? 3QH from this result over here minus QH. So finally we'll have that Q prime C minus QC will be equal to 2QH. So basically that is saying that, again, the irreversible cycle will be putting into the cold cycle twice the amount of heat as the reversible one. And that's it. Thank you for your attention.